As you're probably aware, almost all of the larger planets in our solar system have their own moons. But our gas giants, Jupiter, Neptune, Saturn, and Uranus, have significantly more moons than all the other planets. They have so many moons we don't even really know how many moons they have. And today we're going to look into why exactly this is. So first of all, we need to understand how a moon is traditionally formed. So when a star is formed, it leaves a disk of gas and bits of rock and stuff around it. Some of which will end up falling into the star and making it larger, but most of which will end up forming the other objects that orbit the star. So planets, asteroids, moons, comets, and miscellaneous junk all falls under that category. But the same thing happens when a planet forms. So there will end up being, if we take Saturn, for example, a bit of dust that's spinning around, and it will follow an orbit around the sun, and eventually enough will gather in so that there's a centre that becomes Saturn, and there will be a ring surrounding Saturn that ends up not falling into Saturn. And some of that has become Saturn's rings, but some of it also made its own little spiral going around Saturn, and that ended up becoming some of its moons, like Rhea. And because of the way these moons form, they're always rotating they're always orbiting in the same way that the planet is rotating. So Rhea will orbit Saturn the same way that Saturn is orbiting. But the thing about the gas giants specifically is that they obviously have a much denser concentration of gravity, and they distort gravity in their local area a lot more than the smaller rocky planets do. And because of this, they have a lot more influence on any objects that pass by them. So any asteroid that happens to get close enough to any of these gas giants will get bent out of the orbit that it's following, and if it happens that everything lines up just right, it will get bent into an ellipse around that planet, and it will end up becoming that planet's new moon. So the big differentiating factor between these asteroid moons and the traditionally formed moons, aside from the fact that the traditional moons are generally larger and the asteroid moons are generally smaller, but not always, is that because the asteroids are just coming in from whatever direction, they aren't necessarily going to orbit the gas giant in the same direction that the traditional moons are. So you end up having a whole bunch of moons that are really far away from the gas giant, some of which are not orbiting in the same direction that the gas giant is rotating. The one exception to this is Neptune's Triton. Neptune is pretty far away and people don't really think about it that much, so of course, like those small towns with their giant balls of yarns and miniatures of themselves, Neptune had to come up with its own gimmick so people would actually pay attention to it. And its gimmick is that it has a very large moon that is orbiting in the opposite direction to how it's rotating. But the mystery isn't as deep as it seems. It formed in exactly the same manner as asteroids orbiting these gas giants did. Once upon a time, Triton was actually a dwarf planet, orbiting in the Kuiper belt, the same as Pluto is and other dwarf planets. But at some point it just happened to pass close enough to Neptune to get pulled in, and is now likely to live out the rest of its days as one of Neptune's moons. So just think about that next time you feel upset that Pluto lost its planetary status. At least it's still technically a kind of planet. I hope you enjoyed today's video. I hope you found it informative. As usual, I've left some links down in the description below if you would like to read more about anything that I've said today. And of course, if you have any questions for me or anything else you'd like to say to me, feel free to leave that down in the comment section below. And I'll see you next week with another video. See ya!